Have you any time pondered whether we're really alone in the universe? Then again, assuming there's something more to our existence other than what we see, envision a situation in which the James Webb telescope finally shows that we live inside a dark hole. Join us as we find out more about this vital news that will make you question all that you thought you knew about the universe. So, what exactly are dark holes? They're like something out of a bad dream. Sure, you might have seen them in sci-fi motion pictures, but they're significantly more frightening. They're not just that, as shown by analysts. Thoroughly, dark holes in space are considered enormous amounts of matter fit into an incredibly small area. Consider a star, several times more enormous than the sun, all packed into a circle the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been enraptured by dark holes for quite a while. From that point forward, they've considered objects in space so monstrous and thick that they could trap light. The most well-known ideas about dark holes were predicted by Einstein's theory of general relativity. Essentially, when a gigantic star says no thanks to it, it abandons a thick center. If this center's mass is several times that of the sun, gravity overwhelms everything, leading to the formation of a dark hole. It is not easy to identify dark holes since they radiate no light. Anyway, analysts have tracked down ways to induce their presence by noticing their effects on neighboring matter. For instance, if a dark hole passes through a cloud of interstellar matter, it will pull that matter towards it in a process called accretion. Moreover, when a typical star gets too close to a dark hole, it can be destroyed, emitting X-rays as it does so. Dark holes also have enormous effects on their surroundings. They can consume nearby stars, emit strong gas blasts, and even affect the formation of new stars in some regions, while slowing it down in others. But where do dark holes come from? Picture stars, once magnificent and exploding, meeting their ultimate fate in a stunning explosion called a supernova. From the remains of these fallen giants, dark holes emerge. Most dark holes are born from massive stars that have reached their heavenly retirement party in a supernova blast. Smaller stars, when they die, turn into something many refer to as neutron stars, which are incredibly dense but not dense enough to trap light. Anyway, if a star is several times the mass of our sun, it collapses under its own gravitational pull, forming a dark hole. As powerful as these collapses are, something strange occurs near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time seems to slow down near the event horizon, the last point of no return for anything falling into a dark hole. Perhaps the star's clock ticks at a different speed compared to ours. Occasionally, when two smaller dark holes collide, they merge to form a significantly bigger and more frightening dark hole. And if a dark hole interacts with a neutron star, they create a nightmare that defies understanding. Scientists have been grappling with the size of these massive phenomena for quite a while. Dark holes come in two sizes, big and small. There's an evil mystery surrounding them that we really can't unravel. However, here's the twist. Small is relative when it comes to dark holes. Very big dark holes, the remnants of monster stars, can be as gigantic as 10 to 20 times the size of the sun. There could be upwards of 10 million to a billion of them in the Milky Way alone. That's a cosmic number of dark holes that could swallow anything in their path. Anyway, hold on, there's something even bigger. Very gigantic dark holes are at the other end of the spectrum. They are millions, if not billions, of times greater than the sun. They exist at the center of massive galaxies, including our own Milky Way. It's like a massive, dark void pulling everything toward it. The renowned physicist Stephen Hawking discussed dark holes throughout his life. His lectures were always insightful. Some of his theories couldn't be confirmed due to a lack of necessary equipment. Anyway, there is hope on the horizon. A single scientific instrument is making a huge difference, and we're not ready for it. It goes by the name of the James Webb Space Telescope, otherwise known as JWST, and it's here to dive into the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, an exhibition of the power of human ambition. Sure, we've launched other space telescopes before, and they've done their job just fine, but this bad boy is truly astounding. The JWST makes the Hubble, which has served us for years, look like a basic speck in the universe. The price tag of this cosmic wonder is a staggering $10 billion. Yes, you heard that right, that's enough zeros to make your head spin. And get this. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, along with the precious contributions from over 300 universities. But let's not forget the dangers that come with such a fantastic endeavor. I know this isn't a task for the faint of heart. The JWST is venturing into strange territory, stretching the boundaries of what we know, and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its base mission life. Since its launch, the JWST has achieved countless unimaginable feats, traveling over 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sunshield and gigantic primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has aligned and adjusted it, the telescope is nearly ready for full operation. One of the most fascinating parts of the James Webb Space Telescope was when NASA reported that it had captured its first pictures of starlight. The first picture taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots from the star's light, captured by the 18 mirror segments on the primary mirror. NASA later released another truly amazing image of HD 8446, in which the 18 unfocused duplicates of the star were combined into an intentional hexagonal arrangement. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process, combining the 18 images into one clear view. Thanks to its cutting-edge technology, the JWST will help researchers examine the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This period refers to when neutral hydrogen was reionized, made to have an electric charge again, by radiation from these first stars. This includes looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also assist scientists in finding exoplanets, which are incredibly difficult to detect due to the way they interact with their host stars. Its powerful sensors will be able to observe these planets in more detail, including, in some cases, imaging their atmospheres. Understanding the environments and conditions of planets could help scientists better predict whether certain planets are habitable or not. Besides studying the formation of universes, researchers are studying galaxies to understand how matter is organized on a large scale. This, in turn, allows us to see how the universe has evolved. The spiral and elliptical galaxies we see today evolved from different shapes over billions of years. One of the JWST's goals is to look back at the earliest galaxies to better understand their development. Scientists are also trying to figure out how we got the range of galaxies that are visible today, and the current ways galaxies form and accumulate. But most importantly, the James Webb Space Telescope will help us answer the most fundamental questions of all. Are we alone in the universe? And are we living inside a dark hole? The JWST has already been on the hunt. And guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, hiding around those massive, supermassive dark holes in 3 active galaxies. These carbon-based molecules with ring-like structures are like the goth kids of the universe. They're everywhere, from distant galaxies to comets in our solar system. Now, they're not just interesting because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This is often a sign that there are some hot, young stars hanging around. But wait for the twist. An astrophysicist, Ismael Garcia Bernard from Oxford University, decided to study 3 active galaxies known as NGC 6552, NGC 70319, the famously renowned Stephan Quintet, and NGC 7469. These galaxies are millions of light-years away in the depths of darkness. Now, what Garcia Bernard found will make your hair stand on end. In those central regions where the dark holes dominate, he found a mass of PAHs. Sounds incredible, right? Well, here's where it gets chilling. The radiation near those supermassive dark holes distorted the PAHs, changing them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into oblivion. Imagine being consumed by the darkness itself. But wait, there's a glimmer of hope, or maybe not. The ultimate question here isn't whether we're alive. Instead, if we really exist, does everything around us exist because of the dark hole we're in? Everything connects with the theory that maybe we're not just living inside a dark hole, but rather inside the event horizon, a line between the universe we know and the unknown. Could it be that everything is connected inside a dark hole? The James Webb Space Telescope is out there right now, searching for the answers to the unknown. Stay tuned, and perhaps, just maybe, it will make all of us reconsider what we thought we knew about existence. The truth might be far more twisted than we realize. As the James Webb Space Telescope continues its mission, it will push the boundaries of our understanding and possibly answer questions we've been asking for centuries. It's not just a telescope. It's a window into the deep mysteries of the universe. Its findings might not only reveal the secrets of dark holes and exoplanets, but also help us understand our place in the cosmos. Will it answer whether we are truly alone? Will it help us discover other life forms, perhaps hidden in the depths of space or in the atmospheres of distant planets? The JWST's powerful instruments are capable of probing far deeper into the universe than any telescope before it, revealing structures and phenomena that were previously invisible to us. It's a tool that could change everything we thought we knew about the cosmos, about gravity, and even about time itself. The more we understand dark holes, the more we may come to realize how interconnected everything in the universe truly is. Perhaps we are all part of a larger cosmic story, one that the JWST will begin to unravel. But the answers it uncovers won't come without more questions. The more we learn, the more we might wonder about the true nature of reality. Are we simply passing through a cosmic experiment? Or are we, as we seem, part of a greater plan, one that stretches across dimensions we can't yet comprehend? The JWST will be at the forefront of this inquiry, looking at the universe in ways that challenge our imagination and understanding. What's more, the telescope will likely change the future of space exploration and the way we think about other galaxies, stars, and black holes. As we move further into the unknown, the JWST promises to help unlock the deepest corners of space, perhaps allowing us to understand things like the Big Bang, dark energy, or the true mechanics behind gravity. It's a thrilling thought that with the aid of this remarkable machine, humanity might uncover answers that have eluded us for millennia. As we sit back and watch its discoveries unfold, one thing is certain. The James Webb Space Telescope represents humanity's thirst for knowledge, our unyielding curiosity about the universe, and our drive to understand the unknown. It's more than just a project or an instrument. It's a reflection of who we are as a species, looking to the stars not just for answers, but for understanding.